Yesterday we finished off with x squared, natural log of x. Today, we're gonna start with a question that says integration of arcsine so again, let's just review a couple things yesterday. Yesterday we start with this. Oh, we end with this one, right? We went end with x squared natural log of x, and we say this is integratable. So if it's something that's integratable, then we stop. We're just gonna integrate it because two things happen. One is if I keep on taking derivative 1 over x, it's endless. It just keep on going. It doesn't have a termination point. It does not terminate. If it terminate, then it's good, but it doesn't show that it's terminate. So then let's look at the horizontal perspective here. That's integratable, then I'm gonna integrate it, and I'm gonna get x cubed over 9.
Is there like an algebraic way to determine if it keeps on going, like if it keeps like if it never goes to 0, or do you just have to see it?
You just have to see it. I mean, x to the -1, keep on taking derivative, it's going to be x to the -2, x to the -3, and the constant is going to be like factorial. So it really doesn't really, you're not going to stop. So you're going to stop right there. So knowing when to stop on the integration by parts is very, very the key. We're going to study 3 situations that we should stop, right? Yeah.
So like we stop here because if you multiply the two, you can do the integral of it?
Yeah, because it's just simple integration of polynomial.
Yeah.
I mean,
what did you integrate? X cubed over 3, right?
Times 1 over x, because you can actually just integrate the horizontally like this. With the negative sign though, be careful with the negative sign.
And then, for example, say you couldn't do like x cubed over 3, you have to do another integral? Like you would multiply like diagonally? Like
Yeah, so for example, like this particular case, right? It's x e to the x. I'm set d. Remember, it's liate. You don't want to do e to the x. E to the x is the last priority to set d. But you got x1, e to the x, e to the x. Now, this is a 0, right? 0, you stop. Then you're going to go like this and just write out all the terms. So it'll be x, ex, and negative e to the x. Negative e to the x plus c, and that's it. You're done. But remember the plus minus plus sign, just write it always out there, because that's how the order of pi parts is. So at first, this is the first question we showed you yesterday. This is by part. By parts to figure out what u equal to x, du equal to 1 dx, dv equal to e to the x dx. V must be e to the x. Now if I integrate this, I'm going to get x ex minus ex plus c. I can use by parts to get the same thing. But there is an advantage of DI method because a lot of situation, it can be a different situation. Last period we did different situations. So this is the second case that we did. I think we end with this yesterday, right? Is that right? Okay. So we're gonna do arcsine. Now remember, when the moment is integratable, it should stop. And the other side doesn't go to 0, right?
Which method are we doing?
DI. But this one, DI and the integration by chart is pretty much the same thing. So when do you stop, right?
Oh, okay. Integral. That's what you're trying to say. 1 over square root 1 minus x.
So we stop here. Do you see why you stop?
You can do a u substitution.
You can do your substitution right there. You stop here because it's integrable. So that's going to be x arc sine of x minus integration of x square root 1 minus x squared dx. And not just simple u substitution. So it'll be x arc sine of x minus integration of square root of u x du over minus 2x. So that becomes plus plus 1/2 u to the 1/2 du. Now this is a u to the 3, this is a negative half, so it's going to be 1/2. And this 2 and 1/2 is going to cancel out. Two cancel out, so it'll be x arc sine of x plus square root of 1 minus x squared dx. Oh, plus c. And we just finished.
Why do you put x over root 1 minus x squared?
Because I do u substitution. This part is u, right? The x still there. But if I evaluate the du, I will have dx and du over 2x. So this x will cancel out here, so everything gonna be in term of du.
Yeah, but why is it an integral in the first place?
Because when you do a horizontal, it's gonna be integral. When you go down here, then it's gonna be this like this. But the problem is this derivative is not become 0. The derivative is of that is actually become more uglier than before. And you have no option but stop.
Like, if you don't stop, would it still work? Or just stop?
It will not work because derivative of that it's gonna be a lot more ugly than before.
Yeah, I get it. Yeah.
Would it technically work if you kept on going and like stopped at just a random place?
I don't.
No.
Because like yeah, the next one will be x squared over 2, then like you can't do that. Yeah.
You're gonna have degree is different. There's a differential here.
That would technically still be true, like the equation that you set up, even if you can't take it. I was wondering.
Yeah.
It won't be true. But you can try it, but it won't be true. You stop there because once integrable, integrate. Is that okay? Okay, so you guys gonna try this one. And I'm gonna ask you to throw a different number too.
That was like
If it can go to 0, you can go just stop at 0 and just write everything out. So that's a nice thing.
What is that? How does it go to like, so just like x squared x? That's what goes into the. It should look like this. This is like I think I don't when it's this, but I definitely before. Is you write the u here and v here. Okay, there you go. I think that kind of helps me.
So that's two questions where DI method start becoming better than integration by parts because before it's really similar. Now this two question is by parts is gonna be you had to take two by parts. You had to set UV and then you integrate the other one, and the other one you had to do UV again, and then that's why you had to do by part twice, which is much more annoying. Or if you DI method pretty much 3 line, you pretty much will get it done to the whole answer.
It's only ever 3 lines for DI?
Why is
Is it always gonna be just 3 lines for DI?
why are you doing integral of 0?
What did you mean by if it goes to 0?
Well, what you what the D has to be here. Yep. So this will eventually go to 0, right? Right? And this is going to be sine of x. What's integration of sine of x? Negative cosine of x. What's integration of negative cosine of x? Negative sine of x, right? And it'll be cosine of x, right? So all you gotta do is do here, boom, 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 stop. So it'll be x squared negative cosine of x.
Oh, you multiply every line?
Yeah, and this is not negative sign, so it's gonna be plus 2x sine of x and plus 2 cosine of x and then plus c, and then you're done. By part's gonna a lot more work. You had to do UV first for the first one, and you're gonna get a second one still required by parts, and you have to do that again. This DI is called tablet method. Actually, I'll show you a scene of a movie. It's actually exact same thing. Let me see if I can find it.
So there's no integrals?
No, you just write out, you just multiply everything.
That's why I was taking the integral of 0, because at the end, when you take the integral of 0 times cosine, you just get 0, so you don't like.
Yeah, you know, you can.
Oh.
What the integral should be integral cosine of x, but 0 times cosine of x is just 0. Yeah. So stand up and teach. I think. Oh, stand and deliver.
Monsieur, was the other one x squared cosine 4x or just x?
X squared cosine 4x.
I can't find a thing, but this is a pretty decent movie. But yeah, this has multiple parts. You guys got it? DI x squared plus minus plus 2x and 2 and 0, right? And this is a cosine of 4x. Sine of 4x over 4, right?
Is it negative?
No, derivative of sine of 4x equal to cosine of 4x. And what's the next one? second. What's the next one?
Negative sine 4x over 64.
Sine of 4x of what?
64.
1 over 64, right?
And negative.
If I take negative, that's gonna give me negative, okay. So all you gotta do is pair them up. And you're gonna say x squared 1/4 sine of 4x. Now this is gonna be plus 1 over 8 2x cosine of 4x. Is that okay? Yeah, because 2 times 1 over 16.
You added the 2 again.
Huh?
You added the 2 again.
Oh yeah, you're right. So this is this one just 2x. This one just x. Yeah, you're right. And what else? Minus 1 over 32 sine of 4x plus c. Is that okay? Okay, we'll stop here. Now this is all pretty easy. Things gets kind of hard if you have a different situation. So yeah. So ex sine of x dx. Oh, let's do sine of 2x.
You know the guy on TikTok who has like the pens? He just like
Red pen, blue pen.
yeah, he just does the integral and he keeps like adding stuff and like to make this natural law. Can't explain it very
No, I know which video. I saw that video.
I don't know which one to make here.
LIATE. So your D is gonna be in this order. So in this case, the problem is the order is T and E. It's all the way in the end. Trig and exponential. So this one is gross. And gross means, it's just a little bit harder. So what we're gonna do is we're gonna say DI. And we're gonna do plus minus plus. And this is also DI is better than the integration by parts. So D is gonna be in this order. So Austin, what would be my first boxes here?
Sine 2x.
Sine 2x. Okay, good. Sine 2x. But do you know what's the derivative of sine of 2x?
2 cosine 2x.
No, negative 2 cosine of 2x.
TV positive.
What?
Derivative sine, cosine. Cosine derivative.
Oh yeah, sure. Remember, I was thinking about integration. Sometimes you get confused. And what is the next one?
It'd be 4 negative sine x or negative 4 sine
Negative 4 sine of what?
2x.
2x, good. So this one's e to the x. E to the x is easy. E to the x, e to the x. It seems like the problem is e to the x never change. That's not a problem. The problem is sine of x, sine of 2x, cosine of 2x, they just flip-flop.
Yeah.
They become a cycle. They not like they cancel out. It's kind of different. So I'm gonna stop here and I'm gonna show you the reason I should stop there. But you guys gonna find out why I stopped there in a second. I'm gonna write down the questions. And I'm gonna say, okay, I'm gonna just write it out. So it'd be e to the x, sine of 2x is a positive, right? Negative e to the x cosine of 2x.
Or would it be 2?
There's 2. I missed 2. Yeah, I missed 2. Okay. Now why did I stop here? Because I'm gonna integrate this part because of the horizontal line. ex sine of 2x dx. Do you see why? Jared, why? So what can I do?
You like add it over to the other side?
That's what exactly you should do.
Oh yeah, so it'd be 5. Yeah. Is there a dimension? Yeah, wow. Yeah, then
Hey, smart. Oh, nice. Such a smart guy.
And I'm going to divide it by 5. And that's e to the x sine of 2x dx. And that's why I write down the question, because I write a question so I can use it. So it's going to be e to the x sine of 2x over 5 minus 2 e to the x cosine 2x over 5.
that's cool.
So 3 situation you should stop. You might want to write down the 3 situation. The first situation you should stop is when d equal to 0. The derivative becomes equal to 0. That's the first case, right? That's easy. Let's just write it out. The second case is when they become integratable. The third case is it goes back to the questions. So it's anytime you have a combination of 2 and 3. We're going to talk about one last case, the combination of 2 and 3. It's integratable and go back to the same question at the same time. So this question is very special. It's not like something I will test you, but I just want to show you that it can happen. Okay. So there are 3 situations you should stop di.
I'm just curious. Yeah, so is that d equals g?
D equal to 0. So when the derivative equal to 0, see, this is the part that I stop, right?
Yep. And 2 is you can the integral from left, right?
It's left and right, so that x squared natural log of x 1,
That would work.
that hold on, where is that? Right here is integrable, right? Right here, that's integrable. Right, when horizontal is integratable, then you stop. So when the horizontal, like horizontal, is integratable, the third situation go back to the same question. Now this is the case is kind of weird because this one is actually have both. But it's also, this one's also hard to set up the DI method. But here's a question to you. What you should set as D and what you should set as I. And why that? What is D and what is I?
D is secant.
Is D1?
D is secant. Why is D is secant?
Because
No.
Because you can integrate secant squared.
Exactly. So it's like combination, you two. Good job, tag team. Because
Just say it's secant cubed.
oh, okay. So integration of secant square is 10 of x, right? And derivative of secant of x is going to be secant x 10 of x. And then you can have option to do one more derivative, but you're going to say that's a product rule. That might not be something I want to mess with. And so you say, okay, well, I'm going to try to stop here. I'm going to see where to go there. So the first part is going to be secant of x, 10 of x. Got it? and then it's gonna be minus integration of secant of x 10 square of x dx. And you're like, oh, okay. I don't know what does that mean, but I don't know where to go from there. But this is the part that you should start using trig identity. Because if you use trig identity, it will work. What is tangent square equal to? You were doing not bad, but what is it?
Secant. -1.
There you go.
Yeah, I knew it.
Okay, you were doing good. It's just that the order switch. Now what do you see here though? Oh, what do you see? Secant cube.
Base function.
Secant cube, right? And then plus integration of secant of x, which is, we also know what it is equal to integration of secant cube of x dx. That's pretty cool. I'll just move this to the other side. Right? So this is the two things happen. One's integratable, and second thing is cyclic. It go back to the cycle because you have something you can use on both sides. So therefore, it's going to be secant of x, 10 of x, plus the integration of secant of x we happen to know. Plus 10, plus c. And all you got to do is divide it by 2. And then there you go. This answer is like really nicely done. Now, like I said, let's do calculus 2. I learned to appreciate every time I teach again. So this is the third time I'm teaching this, and I think by the 5th time I'll get pretty expert at it. But this is definitely one of the cool things in integration technique. That is definitely a new technique to resolve a problem. And I was not like what's that guy's name? Neil deGrasse Tyson. He's like, a lot of people says math is not useful. Math is actually challenge you to think differently every time, different perspective. Our other subject is memorization, but this one is like challenge you to think different views each time. And you got a tool each time, and maybe you can come up with your own tool. Richard Feynman is MIT professor. He's not even a math professor. Okay, and you guys can probably look it up. I didn't know the math of it. I know Richard Feynman is like a very well-known MIT professor that is teaching MIT for a long time, teaching physics, and he says, and he actually come up a integration technique as a physics professor. That's called Laplace transform. And it's very well known in the math world. And I wasn't smart enough to understand it, but you guys can look it up. It's pretty cool. They have a lot of different they can solve different kind of problems. So it's called Laplace transform. So yeah, this is all the integration by parts. We did get a chance to go over one more questions. So this one's not by parts. This one's building foundation for tomorrow. So this is not by parts. This is just simple integrations. I mean, if you know how to do identities very well, the reason why I talked about this today, we kind of did that today. I would say we kind of did that today. So pay attention, see if you can figure out this. We kind of do that today. This one's not by parts. Why? Because they are T. They are trig. So is there any way I can take integration that's just using identities? And really simple integration technique.
Just like if there's like every time done this with like 2 different parts? Like this is sin x, cosine x. What if there's like 3? What if there was like x cubed or something? Can you do it 3 different?
Not by parts.
I don't know the word.
And I haven't seen that yet. So
Like, yeah, like imagine a
it
product
doesn't
rule-
mean that it's not there. That's
Yeah.
the
like product rule but with 3 different things. Like would that
like there's no product rule for integration though, right?
or, like even for a derivative, right? Like say there's 3 different things multiplying. Like integrate product would do that. I mean, I don't know. Just
You know, they are a lot of technique. Like a lot of them, it's not in the textbook,
yeah.
and that's something that we know how to. I know how to do. It doesn't mean there is none. There is, for example, there was one of my best student. I can give you that question. One of my best student named Isa, and this question was Stanford integration B questions. He spent 3 months to solve it. Like, you know how that day, that Anthony called me weak? This guy,
That was so funny, bro.
And then you're
Yeah, I was like, bro.
I was like, Anthony being sassy today. All right.
I knew it was gonna happen one day.
Well, you've been planning for a long time. But what you don't understand though, what you don't understand, Anthony, you don't realize is that's the moment probably that I would say I'm probably the most proud student.
student beats the math.
No, this is the only thing that I'm always looking for is someday some students better than me. The funny thing is, 4 years ago, I used to have a student named Sadat, and Sadat is probably the second best student I ever have. In some way, he's the best. In some way, he's the second best. As far as the calculus score wise, he scored computation score. He scored 98. It's pretty tough. And he did it in 2 years. All the Orlando Science kids and Buchholz kids, they studied that math computation for years. He did it in 2 years. Now, what's most impressive thing is I sent a screenshot of what you say, and I sent it to him. Because Sadat used to do that to me all the time. Sadat would be like, yo, Mr. Yi, I bet you don't know how to do this one. Let me show you how to do it. And he was being an ass too. But he was really good. He was really good. But him and Emilio is 2 kids that seemed like you beginning of the year didn't want to do homework, but they come in negotiate with me. They says, Mr. Ye, we're gonna get all 100 on the test. Okay, him, Sadat, Summon, Smith, so all in 1 year, like 5 of those kids, like I forgot how many I get. 5 of those kids, they all decide they're not gonna do homework. And they come in, they say, Mr. Ye, we're gonna negotiate with you. I say, okay, you won't negotiate? It's like, we're not gonna do homework because we already do competition stuff. We're not gonna do homework. I say, okay, fine. Long as you get 100, I'm just gonna put 100 as a score, and they are the score. So, and all 5 of those kids are very special. Like one just went to Stanford, and one of them went Johns Hopkins, and one of them went to UF honors, and they're very, very good. They're very, very good. So Isa's another one. Isa solved the integration B questions by himself. He takes him 2 months. That kid, like, not only he's like, you call me weak, that's true, but that kid is actually, I can call him strong. He had a will to not looking at the answer for 3 months until he solved it. 3 months. I'll show you the question.
Imagine.
3 months. Every day at lunch, he pull out, he write on the board, and he show me different way to solve the problem. He never did anything in calculus. Anything. Nothing. Nothing he did in calculus. That's the only question he did. That's the only question he ever did the whole time. He learned the whole calculus because of 1 question. He learned the whole calculus because of 1 question.
You gotta show us now.
Huh?
You gotta show us the question now. No, not if you find it.
I'll show you in a second. It's great. It's the question, like,
We haven't did integration.
I tried like 10 different way, and I was like, I can't do it. And I gave up in like the 3rd day or 2nd day. And this kid's like, and I was like, I can tell you the answer because I have the answer key, but I don't have the solution. And I said, I can tell you the answer. He's like, nope, don't tell me the answer. I don't even want the answer. I just want to figure out how to do it. And there's multiple choice, so he knows if he get an answer, it's gonna be one of the choices. So he didn't look up the answer. I didn't give him the answer. He solved it by himself, and he solved it 3 months. The person with the most will out of anybody have. I remember multiple choice. He took it half amount of time. 1.5 hour. He take 45 minutes. He got 44 correct out of 45. And he come in late and just take it. The whole time he in my class, he doing Rubik cube.
The same thing that did Michelle did, like by himself.
No, that's Ethan. That's Ethan is smart, but he's lazy. He will not prevail. But he like to invent. Ethan like to invent. He will says, well, I would like to find a new way to solve a problem. And Ethan's special too. Ethan and Isa is like probably one of the most special kids I ever have. Ethan read like this old math textbook for fun. I'm like, I don't understand like 1% of material in there. And he say, I think I understand this. And he will show me like what he understand. And he will use computer program. He will design like a lot of things. He's a computer coder. And he'll code like how to do like integration by integration. He will code computer to use Riemann sum to figure out the integrations. He will code them.
Right.
And that was he's a different beast too. He's a different beast. He's special.
So, I'll just...
So this question,
No, wait, Mitri, I'm so close.
okay.
I'm
I'm told you use identity.
I'm at integral of cosine squared x. I have one more step. I don't know what it is though. What is integral of cosine squared x?
You don't know how to do that yet.
What do you mean?
Do it.
Another okay, wait, hold on. Wait.
Four identities, bro.
Do a power reducing.
Yeah, you can do power reducing, but you haven't learned that. You learn that tomorrow.
Can I do 1 minus sine squared x, right? And then I split it, right?
You can't split to what?
Integration of 1 minus integration of something.
Yeah, that's sort of right. And then I do
Yeah, I don't
minus
know what I'm
integral
looking
of
for.
sine squared x. Okay, what's integral of sine squared x? Do we know that?
Yeah, that kind of
But
thing.
did we do power reducing too?
How do you do it on mobile?
Oh,
You do it on mobile.
It's fun.
Oh, you know what you should do? You should make it. So what's the square? Is it secant square? Then you go. But what about?
Yo, hello.
Never mind. Oh wait.
Wait. That's true.
Something you already did today.
Oh shit.
If you can make it like. What was the thing that's squared that you can make? Is it secant squared that we get the?
Has nothing to do with secant.
Wait, can you just bring out? Oh wait, no, secant.
cosine
Never
x.
mind.
I'm so close to your like I promise you. If you tell me, I'll kill myself.
They still have 6 minutes. Let them do it.
Cool.
You literally did it in the last. Literally, the bell had already rang.
I'll stay past the boat.
I would say everybody have a skill to do this question, right, Kelly? Would you say?
Huh? Yeah, for sure. No.
It's not something I need to teach. That's what I'm trying to say.
Yo, what can I do, bro? What's the do you have your identity sheet? Forget that.
This identity is very easy identity.
Oh.
You don't even need an identity sheet for that.
Was it always
Well,
just
what
1
about
minus
this?
cosine and 1 minus sine? You do that a lot.
Yeah, wait, why can't I do the power reduce?
No, because no.
What do you mean though? It would I'm gonna do it.
Sure.
Like,
I like you. I like your attitude.
what's
I wish you would have do that with. Never mind. Rebuff.
You want to do my part?
You gotta have that same attitude to girls.
I don't know.
No, you don't care about the failures.
Oh, that's, but like, you don't. But shouldn't you use?
No, I think that sucks situation. I think that's a.
Oh yeah, that was a pussy move.
dude? What? I've never claimed to be a fighter. No.
No.
He followed under it.
That's such a.
He hasn't
He followed
followed
under
yet.
pressure.
He's just like he's
Bro, I'm this
But
close.
he's gonna
I'm
say
this
it.
close, bro. This close.
That's what you always say.
No, I've never said I'm close. And like, no, like, actually, bro, I'm saying trust.
But I feel like
Tony's laughing.
make your personality for the girl. And try to please her.
I have never not faked my
Okay, I
personality.
think that.
Yeah, don't fake personality. Just be yourself.
No, I'm just saying.
Oh, well, okay, look, they,
Oh,
they-
at least he has opportunity for that type of.
look,
Come on.
look. They came to my house wearing their opium fits. I thought,
Oh!
What does that mean?
they're so gothic. Like, I feel like anything I say is gonna like, it's like completely
You gotta
different.
be different.
Wait, Sean, she's also like that.
She's,
Bro, why are her friends all?
We're at.
Yo, that's our friend.
yeah.
Oh, so much cheaper right now.
Oh, God. I don't know the name. Some name drop.
For those on stream, my name is Drago. Is the first step
Hey,
Goes
that's
down
the
to where
shit,
I
man.
swear.
Right, you watch this later.
Try to do that.
You can do anything. Just solve the problem.
Oh.
Raval, have you had your first- Wait, Raval, have you had your first kiss?
Yes.
Tony, keep it
No,
back.
I had two, man. No.
Got two?
What do you mean two? From where?
Two first kisses.
Bro. This man knows more about me than me.
Hey, no
Can
name
you
drop.
write that?
Check you as well.
Can you write that?
Drop pictures.
Hold on.
Right out her name.
We get a little emoji going.
You know, my son got his first kiss at 6 years old.
Oh, that doesn't count.
No,
I had a preschool boyfriend and I kissed him.
no. That was like,
Guys, forget about necklace.
what is
Oh,
going on?
No way.
He's right. Her name.
Wait, who is it?
Her name.
Who is that?
Wait,
What
like,
is that?
wait, are they still together? Like, wait, how long ago were they together?
You know who that is?
No.
It was like, not.
Hey, you know who that is?
No, no, that's incorrect.
This dude loves black ones. He's just like me.
I don't know.
Bro, I had to ask her for a second chance. She gave it to me, dude, but like, I don't know. Yeah, I mean,
Wait, that's the
Oh,
one that
how you
hung
doing?
up in the air.
Oh, yeah, but Yo, I got one now.
Whoa!
bro, it was you so? Are you kidding?
Yeah.
What is that?
Are you kidding me?
No, it's not that simple. What is
Yeah.
he doing?
What do you mean not?
No, but like,
Oh,
give me
no, I
a second.
refuse, bro.
I specifically didn't do you so that like I wouldn't have had to like, cause you said it was really simple stuff, you know.
Wait,
Bro,
look
this
at
is
you.
your own identity, bro.
Bruh. No.
I think everybody can do it. This one.
Wait, hold on.
All right, I'm gonna